So can you see that side?
Yeah, okay. Welcome to the webinar on the open source geospatial tools and mobile devices for canal network digitization. We have Dr. G. Paavan Kumar Reddy, who is our young professional, and he has been working in this area since quite some time. In fact, he has done certain amount of pioneering work, especially in mapping the old canal networks which were in existence for a very long time. And it's a very important and very useful experience that he will share with us for the purpose of understanding that how we maintain our assets and how we keep on updating the status of our assets so that we know that what these irrigation assets are delivering. So he has been active with the ICID. He attended the 68th meeting in Mexico, and he has successfully evaluated 698 micro irrigation schemes in 2014 to 15 installations, and with a team of 8 members, and in Andhra Pradesh, and has completed mapping canal networks for 2 medium irrigation projects in Godavari Basin using the field staff without zero investment for digitizing the canal networks. This is where I feel that this webinar is particularly useful, because the minimum cost for survey and investigations and ease of operations by using the devices which are practically available with everybody is something which we need to work on and perfect, so that we are able to carry out the our extension, renovation, modernization works in the best manner possible and with the least amount of time delays. So I now invite Dr. Paavan Kumar Reddy to deliver his seminar. Thank you.
Thank you, sir.
Please continue.
So, welcome to everyone. So, today I am going to speak about webinar on open source geospatial tools and mobile device for canal network digitization. Means previously old irrigation projects and they have constructed on 60s or 50s. So they are not. So due to some reasons, people has included some command areas over there, and canals will be may extend over there. But updation of these canal network, all those things as not happening from time to time. So then, and also for government officials, so putting lots of money over there, so it is not possible at every time. So here we are going to discuss about the open source GIS and mobile devices. So how these tools will be useful for us. So coming to the introduction, so here whatever the GPS device available in market, so these things whatever the giving these coordinates of the particular point, so we can get it from the mobile device also. So we can capture the latitude and longitude. So due to the economic constraints, so it is not able to purchase GPS device all time for single purpose works. So means for digitizing the canal network of particular project, so it is a single time purpose work only, so no need to buy GPS device for single. Then we can use it here mobile devices for this one. So the advantage of this mobile device, so we can capture the photograph of the structures and we can assess the structures so time to time, so updates also will be having over there. So this is our overview of the presentation. So in case study 1 we will discuss about the so how GIS and mobile device alone and GPS device use over here. So in case study 2 we will use the GIS tools, and here we are using the mobile application UN Assign app, so it was developed by the UN WASAT. So and accuracy of the work, adaptability of the field level and conclusions. So then coming to the case study 1, so here we are using the GS tools and mobile device and GPS device. So how these two has vary over there. So this is the case study under water irrigation studies. So now also it was carried out on WALAMTARI, Hyderabad. So here we can see which methodology we have followed over here. So basically for surveying of the canal network, so 18 comprising of 7 members we have went over there in this Guntur channel. So here we are having availability of 4 GPS devices with us, but 3 persons are remaining not having any work. So by with adding advantage of these mobile devices for capturing of these coordinates, so we have included 3 mobile devices for collecting this ground truth data. So whatever the data we have collected over here, so we have processed it in the open source QGIS tool. So QGIS is nothing but quantum geographical information system. So this can process our data, means whatever the photographs we have taken, so we can convert it into the Google Earth extension file. So it can be a KML or KMZ. So KMZ means keyhole markup zip. So whatever the data we have collected, so we can convert these things into the by using the QGIS plugin called photo to KMZ. So after that, so whatever the data we have get it on KMZ format, so it has opened in the Google Earth. So using these spatial points, so we have digitized our canal network. So by using this, so we can overlay it on the Google Earth. Means here two advantages over there, two advantages. So Google Earth, it is showing the satellite image of that particular command area, and we are having the spatial locations. So we can see our canal networks as it appears on the ground, and we are having a spatial location. So using these 2 points, so we can do these two things. So then coming to after drawing the canal network, so we have to represent it on a map. So again we will use the QGIS. So for mapping up this one, so then how it's, so this is the collection of the ground truth data. In first photograph you can see, so it is the road bridge way from road to the field. So they're collecting the data. So in the second photograph you can see it is the offtake point which was fully covered with the weeds. So it is taking off from the water from the main canal. So here we can see on the left side of the photograph, so these are the properties of the photograph. So here it is showing the GPS latitude, longitude, and altitude is average one from the mean sea level. So whatever the photograph we are taking, so by allowing the location services, we can capture this latitude and longitude with every photograph, for every one photograph. So after converting the KMZ file, so whatever we have opened in the Google Earth, so if we click on any one point, so it will show the photograph of that particular structure. So on the top of this one, we can see the latitude and longitude and date and time. So then coming to the right side of the part, so we are having the Google Earth image and our, what we have collected from the mobile device. Then we have drawn one line over there. So by using these two white color line, so this is the canal network. So by using these things, we have digitized the main canals, distributaries, miners, subminers, field channels, everything. So this is the length of the canal surveyed over here. So total 52 number of main different types of canals are over there in this Guntur Channel Medium Irrigation Project. So it is around to 250-kilometer length all over the canals. So here the length covered by the GPS device is 130-kilometer, and length covered by the mobile device is 120-kilometer. So total number of structures collected, photographed structures collected is 373. So here we can see the separation between, so blue color dots it is showing over the image here the data collected with GPS device, and yellow color points it is showing the data by the mobile device. So by using this, so we can draw our canal network. So here you can see on the top of the image it is the river Krishna. Here there Prakasham barrage, actually this is an diversion scheme, that's why I didn't show any reservoir over there. Then coming to this, so we have digitized our canal networks, so including main canal from top to bottom. So distributaries, mains, submains, distributaries, everything. So here we can see after doing digitization, so we have to represent it on a good map. So for doing this mapping, so we are using the QGIS open source tool. So it's user friendly also. So by using this tool, we can add our names of the attribute to these canals. So then we can show it on spatially. So with latitude and longitude with scale as 7.5 kilometer. So then study 2. So here it is the Bhupathipalem Medium Irrigation Project. So here we have different approach from the case study 1. So here we are using the GS tools and open source mobile application. So the methodology is same. So but initially the data collection type is different over here. So on the top side, so ground truth data application here we are using is the UN assign, so which was developed by the UN WASAD. So here after whatever the data we are collecting, so we can send it to the crowdsource platform, so that is UN assign website, so we can store it over there, so we can access it from anywhere. Then whatever the data it is available on the UN website, so we can download all the photographs. So then again same process, we can convert it into the Google Earth extension, so KMZ format, so then we can again digitize, then again mapping. So then how, so in this app the added advantage over here is it is showing the coordinates and it is showing the accuracy of that particular point. So accuracy is matters for collecting the data. So and also here one added advantage over here, we can add the attribute data at the field level only, but in case study one, so it is not possible to add the attribute data of that particular point. So here we can add the attribute data also. So it is the platelet showing the number of structures has collected using UN assign. It is showing on the crowdsource platform of UN assign app. So you can see different points placed over here. So and again if we are selecting any one point, so it is showing the structure and it is showing the caption, nothing but is the attribute. So it is the offtake point. So offtake means OT they are representing. So 3L means third left, so 10th right again. So then it is located at the kilometer of 0.2 kilometer from the that offtake. So by using this, so we can easily identify different structures, so which are located on which canal. So and also if in at field level it is all the times it is not possible to enter the attribute data of that particular point, so sometimes it may be go wrong. So for this purpose there is an edit option to edit our attribute data, so we can edit over here. So and also the benefit of this application is, so it is not possible to manipulate the image, so whatever we have taken it at the field level. So why it is because, so whatever the photograph we have captured over here, it is showing the date and location, so it was printed on the that particular photograph. So due to this it is possible to manipulate the image also. So total 24 number of canals are present, or different types of canals in this project. So around 180 kilometer of length of the canals over there, and 813 number of different types of structures has captured over here, and these things are placed in even crowdsource. So this is the canal network of the Bhupathipalem Medium Irrigation Project. So here we can see main canals with minus distributors, everything over here. So we have added the attribute data. So using this one, so it is showing a map scale of 1 kilometer. So it was developed using the QGIS open source tool. So here the accuracy of the work matters over here. So how we have to define? So it is the purpose of the work has to be clarified. So suppose if you want to collect the ground truth data for the canal network digitization, so we have to collect it with the accuracy level. So suppose if you will see photograph of the right side, so here it is showing that the top accuracy 4 meters. So accuracy 4 meters in the sense, suppose if you are taking any photograph of that particular point, so our point spatially will locate within the radius of 4 meters from the particular point. So sometimes the accuracy may go beyond this one also. So for that we have to stay for this one accuracy. So then again the GPS devices, whichever the accuracy it is giving, so mobile devices are also giving same accuracy. So and also you can see with using even assign app. So and finally the digitization of the canals, so here it depends on person to person. So some persons will do it properly, some persons will may go wrong. So for digitization, so here it needs training for persons to do the canal network digitization. So then adaptability So then how to adapt it at field level? So on an average, every person can walk around 8 to 9 kilometers in canal in the command areas for collecting the ground truth data. So nowadays, whoever the field staff, they are having the smartphones and they are very well versed with their operations. So then we can use these people for collecting the ground truth data. So there is no need to technical knowledge on this one. So simply taking a photograph, entering of the attribute data, it is possible with everyone. So and every irrigation department is having minimum on computer. So then we have to train in this way. They have to acquaint it with this open source tools, and these tools, whatever the Google Earth Engine or QGIS or this UN assign up, so all these things are user friendly. They can lend it on their own also. Then coming to the conclusions, so for this, so no investment is required for collection of the ground truth data to the processing of the data and get the output. So no need to depend on any other agency or any other person. And also processing of data can be done in these open source tools. So then coming to the photographs, whatever the photographs we have collected over here, so this will tells us the current situation of that canals. So suppose if you are taking the different type of structures placed over constructed on the canal, so by year, so some structures may collapse. So for that, if you will take photograph, so it will tells us the current situation, and we will whoever the field level staff, they can show it to their superiors. And efficient manpower, so we can use the manpower at efficient level, and also we will get the precise work, and persons will be acquainted with their canal networks. So and also here I have to include a point over here. Suppose if any new irrigation engineer is coming to take as a charge of that particular project, so first they need to know so where the canals are going, so on besides of which villages which canals are there. So for this they have to first know uh, previously if anyone can done this type of works, so they will get to know. So this type of this many canals are getting over there. And also if any canal is beside of the village, so if any village farmers are not getting water, so they can immediately respond for that one. They can immediately remedy that one. And coming to the conclusions, so here there are some limitations this ground truth data using these mobile devices. So sometimes mobile device takes time to connect with the location services to get the coordinates of the particular point. Sometimes accuracy may go over beyond the 20 meters, and sometimes it may go thousands, 10,000s also. So at the initial stage, for this, some patients should be there at the field level staff to get to accuracy of the less than 5 meters. So if our accuracy of the collection of the data is less than 10 meter is permissible, less than 5 meter is very well for this one. So the battery problems means if you will continuously use the mobile devices, so there may be low battery problems. So sometimes poor satellite connections also will be there. So because of some obstruction like trees, if you are collecting the trees or forests, so to get the location, so it will take time, or it will not show that particular level. So here you can see the so how GPS devices are working. So mobile devices are also working on the same principle, so triangulation with the satellites. So suppose if any one satellite is connecting to the our mobile device, so means the distance between these two will place it on the sphere. Suppose if any two satellites are connecting to our mobile device, so it will place us on the circle, so flat surface. So suppose if three satellites are connecting to our mobile device, so it will place us at on the particular point. So here accuracy is the important matter for us. So suppose if four satellites are connecting with our device, so it will show the accuracy of the particular point. So that's why accuracy is important over here. So and finally, so the attribute. So in the case study 2, we are collecting some the added advantage over here, attribute data. So we can add the attribute data at field level also. So but at the case study 1, so it is not possible to add the attribute data. So these are the acknowledgements. So WALAMTARI and Water Resources Department of Andhra Pradesh, and some key references. And finally, thank you. Hello.
Yeah.
Yeah. So thank you, Mr. Reddy, and it was a very interesting and a very enlightening seminar. And we can now open the. Yeah, we also have VPH Ian Mackin with us. So after this webinar is over, we will have a chat with him also.
Okay,
And
sir.
now we can open for the questions
Okay, sir.
from participants. So let us hear the participants.
Paavan, have you published this work anywhere?
No, sir, not yet published. I want to publish it.
Maybe you can develop some guidelines for implementing the methodology you suggested.
Yeah, sir. I will do that one, sir. So already I have prepared for case study 1. So now I am preparing for the case study 2 also.
Another question is that can we have an app wherein we can know that how many satellites are connecting, so that the person can be asked that you don't move from this place till about 3 satellites are already connected to you.
No, sir. So I will tell you the reason over here. So in the UN assign app, so it is showing the accuracy for us. So suppose I will show you the photograph of that one. So you can. So sir, is it audible to you?
Yeah.
You can see here accuracy, it is showing the 4 meters. So while taking the photograph, it will show us, sir. So while taking the photograph, it will show us the coordinates and the accuracy. So accuracy should be less than 10 meters. So while taking the photograph, so it is the permissible limit for us to take the photograph at that accuracy level only. So suppose if it is beyond the 10 meters, maybe our photograph will fall spatial on the 10 meters away from the our location. So that's the reason over here. So while taking the photograph on the camera itself only, it will show this accuracy while using this UN assign app. So there is no need to depend on some other applications also.
Right. Good.
Okay. Yeah. Thank you for the clarification.
Amali has a question, I think.
You can give the speaking right. Amali has a question. We are giving him a speaking right so that he can directly raise the question himself.
Okay, sir.
Amali, he is self-muted.
Amali, have you self-muted? A question we can.
As he timed out, then we can.
No, he is not activating it.
It's a question for you. We can speak the question.
Can you hear me now?
Yeah.
Hello, good morning from Amman, and thank you very much, Engineer Paavan, for your excellent webinar. And I really enjoyed listening to use of low-cost devices for canal network digitalization. I think it reduces the cost of irrigation and drainage, which is all most times the challenges of adoption. My question was mainly about duplication of data and the accuracy, or if I may use the terms, verification of the data. First, on duplication of data, if after your field work, scenarios could arise that somebody goes to the field and does something else, and you may have on a certain canal, you have a tendency of more than one photograph or more than one images taken for that particular spot. And that brings about also the question of accuracy. When taking photographs of structures along the canal, for example, I would assume the field operator does not stand in the canal, but outside the canal at a distance. Right? And so if I have a particular structure, let's say a weir or an open or a gate or a sluice gate along the canal, how do I know that the photograph taken about the structure is exactly at the position, knowing that the person did not take the photograph on the structure?
Yeah. So here we will collect the photograph of that particular weir. So using two photographs. So we can use two photographs over there. So, and you were asking about how you can know about the particular location of that weir. So over the image. So is it right, Amali?
Yes, that's it.
Yeah. So suppose if it is an where, so you can see on the both sides you have to collect the data. Means on the upstream side, on the downstream side. Suppose if you'll say, okay, you have to take the photograph on the upstream side one side and the downstream side on the one side again. So then we have to analyze these two things. So for assessing the structure.
Okay, can I add something?
Yeah.
So we are working on the same thing here in Amman for my master thesis, because I'm also using mobile devices for calculating evapotranspiration and more like remote sensing data using the mobile devices. And we had to use this recommendation because some of the canals, like I stated, we couldn't go inside the canal to take a picture in the stream or in the water source. And so maybe providing a safety distance, like some vertical and horizontal distance, knowing that the person cannot stand in the canal or at its very spot to take the image. And so we have, so all images are provided at, let's say, 4 meters vertical and 4 meters horizontal, more like a safe distance. I don't know if this could help, because somebody may want to contest that the accuracy or how deep, or what is this extent of deviation of this particular image from the spot where the structure is located.
Yeah, it's a good point. So here, so we have to stand away 5 meters away from the structure. We can take the photograph. So we can zoom it to the structure. We can take the photograph also. So suppose sometimes inaccessible areas also available in this command areas. So for this, we have to use the high resolution satellite data. So, but it is too much cost for us to collecting the data. So suppose we can say Cartosat or Worldview. All these things are about to 0.8 centimeter to 0.8 meter to 1 meter data. So we can see on the image directly. So, but purchasing of those data sets is not that much viable at this moment for digitizing the canal network. So otherwise we can use the data sets. So here it is available at 10 meter resolution. So to see the inaccessible areas only. Okay.
Okay, that's good. Thank you very much.
Eddie,
Yes, sir.
Adam Marsha, we are giving speaking right to you, so you can also give your views or some suggestions or some questions. Ade?
Good afternoon, everyone. It's past noon here in Ethiopia. I'm a bit late and I didn't attend all of the presentation, but I see that it's already interesting and the topic was interesting also for me. But because of some issues, I was delayed and missed some important parts of the presentation of Paavan. Thank you very much for the opportunity. I will listen to the discussion here.
Okay.
Okay.
Iman को देखना चाहिए. Yeah, please.
Yeah. Iman Rasool. Iman.
Ian McKin.
इयान मैकिन के साथ तो फिर अलग से बात करनी है.
नहीं इसमें जनरल.
Yeah, okay, yeah.
You can say.
Yeah. Hi, Ian. I think you would also gone through the seminar, so maybe we can listen to your views on this important topic.
Certainly, I'll be very happy to make some comments. I noticed there was somebody else from the attendees that wanted, Rafat.
Rafat. Yeah.
Rafat Nile. Let him go, and then I'll make some closing comments, perhaps.
Okay. Yeah. Rafat, I'm just. Yeah, Rafat. Rafat, can you hear me?
Question mark.
No. Yeah, I think it's.
Yeah, and anybody from the audience, if they want to raise some questions, then they can raise they can click on the hand, and then we'll see that who wants to speak, and then we'll give the speaking rights from here.
Rafat, can you hear me?
Yes, Mr.
Yeah, please continue.
Thank you for this important presentation. Can I talk now?
Yeah.
Can I? Yes. Hello. Thank you, Mr. Paavan, for your important presentation. I still remember before 15 years when I started work with the Ministry of Water Resources, how the survivor in my office by freehand and pencil the canals, and now this free and good technique using GPS, using QGIS, that's mean we can do better things for digitizing our canals, not before 10 years or 15 years. And thanks for Mr. Paavan to highlight on this new technique. I think we should all engineers, all techniques, use these important methods to digitizing our canals. Yes, thank you, Mr. Paavan.
Sahar Narozi.
Yeah. Yes, Sahar Narozi from Iran. We are giving speaking right to you. You can also now speak. Sahar.
Sahar? I think she's self-muted. Close the one.
Okay, so now I think we can request. Yeah. So now we don't have any pending questions, so I would request VPH Ian to give his concluding remarks.
Okay, thank you. Paavan, thank you. It was a fascinating presentation. I've been looking forward to it ever since I got the invitation, and I'm delighted to see the work you've been doing. It is in fact very similar to some work we're doing here at IMI, and I'll write to you separately to see how we can can collaborate to take this forward. We're developing a system called SAMS, Systematic Asset Management for irrigation, and the processes you've laid out are exactly what I think we want to promote for irrigation departments, to firstly update their inventory of assets, but then to go to the next step of managing the asset. I think one of the things that we continually struggle with as a profession is we can build things pretty well, we can design things pretty well, and then we fail to maintain them, so we have another opportunity to rebuild them. And I think the donor community and our users are increasingly requiring that we break out of that cycle. And the work that you've done, I think, is a very good contributor to the way of moving towards asset management. And I think the work we're doing and the work you're doing would actually complement each other very well. Again, using open access tools to the extent possible, and to move towards crowdsourcing the information from the field direct into the database. And I think we might have some tricks we can share with you, and hopefully you can share a few tricks with us as well.
Yeah, sure.
One thing I would like to discuss, not necessarily today, but with ICID in general, is how we can start to use drone technology to complement the approaches that Paavan has presented. I think there is opportunities now to use drones to answer some of the questions that were raised by Amali, how we can actually collect more precise data in the field without exposing staff to danger. I just watched a video of some of my colleagues installing equipment in Pakistan, and if the health and safety people ever saw it, they would have a heart attack. So I think, you know, canals are dangerous places, and we need to find ways to utilize modern technology to safeguard staff, but also improve the quality of the data that we are collecting. And again, I think some of the approaches you've taken and outlined today would complement that greatly. So I'm very excited, and I think through the working group on modernization, we can explore how we can take this work further and promote it. I hope you're coming to Bali next year, and we can have a case study as part of the international workshop, which the call has just gone out for. I encourage you to put in a paper to that. And as I say, I will be writing to you separately to discuss how we might collaborate more in taking this work further. So thank you. It's been a really interesting afternoon. Thank you.
Thank you.
Okay, thanks.
But in the end, if because Sahar Noraji wanted to raise some question, but there is a problem with her site. She is self-muted. We cannot give speaking right from here. So we'll close the seminar, and in the end, I'll thank Paavan for a very interesting presentation, and for which led to lively discussion and suggestions and comments and observations. So thank you very much, and we'll look forward, as VPH Jan has said, that we'll look forward for your contribution in the working group on modernization and rehabilitation, and then they are organizing a workshop in Bali. So we look forward for your paper in that workshop. And thank you, VPH Jan, for acting as a panelist and giving your concluding remarks, and then encouraging our YPs for their participation in our activities as well as in working groups. Thank all the participants who attended this webinar. The live recording of this webinar will be available on our website for those who have missed this webinar or those who want to see the webinar again or share with the others. So this will be available in a few days. In I think 3 to 4 days, it will be available on the website. Thank you all once again. Thank you.
So thanks for ICID. Thanks for VHP and Makin for making good comments. Sure, I will send the paper also, sir. So thank you. Thanks for encouraging the YPs.
Thank you. Thank you.
Thank you. Thank you. Have a great afternoon, and I look forward to seeing the paper.
Bye.